Today we're going over problems from reporting category 3. So our first question, a student is ordering a flower arrangement. She can choose any combination of roses and carnations for her flower arrangement, and she does not want to spend more than $30. If each rose costs $3 and carnations cost $2 each, which inequality represents all possible combinations of X roses and Y carnations? So right there they tell us that X is roses and Y is carnations. So I know roses, X, cost $3, and carnations, Y, cost $2. So we have 3X and 2Y. $3 for roses and $2 for carnations. So immediately I can mark out C and D because they are not properly labeling the amount. Next one, she does not want to spend more than $30. So she's okay with spending exactly $30, but not more than. So we want this amount to either be less than or equal to $30. So our answer would be B. Next one, a drummer and a guitarist each wrote a song for their band. The guitarist wrote 8 fewer than twice the number of songs that the drummer wrote. They wrote a total of 46 songs. Which system of equation models this situation that the drummer wrote D songs and the guitarist wrote G songs? So we know the guitarist wrote 8 fewer, so the guitarist, his amount that he wrote is 8 fewer than twice the number of songs the drummer wrote. So twice the number of songs would be 2 times the number, and 8 fewer than that would be minus 8. So they kind of write it backwards. And then we know together they wrote a total of 46 songs, so we have a total of 46. And together, together they wrote that. So the guitar songs and the drummer songs is 46 total songs. So we can go ahead and look 2D minus 8. So that one looks good. Let's check the other ones. 8 minus, because we're not subtracting on the songs away from it. 2G minus 8, that one looks good. But then this one's got the drummer equal again, so that's not correct. Drummer equals 8 minus, so A would be our answer. Our next question. The graph of a linear function g is shown on the grid. Which inequality represents the domain of the part shown? So remember, domain is your x values. We're going left and right. So we want to see how far left and how far right these graphs go. So right here we have a value of -9, and here we go to 2. And remember, domain x values, so we can mark out C and D because g of x is the same as y, which is range values. So we go from -9 to 2. And remember, these open circles versus closed circles, this means not equal to. This one means equal to. So we would see here is not equal to, here's the equal to. That would be our answer. Number 18. The table represents some points on the graph of a linear function. Which equation represents the same relationship? So let's go ahead and look at this. Remember, we have y minus y1 equals mx minus x1. So that is the formula they're using here. It's called point slope. So let's try and figure out what point they're using. 26 and 20, or 268 and 20, those same numbers keep popping up. That means they're using these points. So let's go ahead and start plugging some of this stuff in and see if we can narrow it down. So y minus our y1 value would be -268. But remember, the formula is minus, so we're going to turn this to a plus 268. And then x minus -20, so plus 20. So we know it can't be B or D. Now we need to find the slope of this. So let's find our differences here and here. So we're going to take this, and we're going to do -196 minus -268. So it'd be 72. We've got -14 minus -20 over 6. So our slope, our m, would be 72 over 6. Simplify that, and we'd get 12. So our slope is 12. So our answer would be C. Last one on this page, the value of y is directly proportional to the value of x. If y equals 35 when x equals 140, what is the value of y when x equals 70? So right here, directly proportional, that means we're dealing with direct variation problems. So remember that one, we have k equals y over x. So we can use this to actually set up a proportion. So we know these go together. So when y equals 35, our x is 140. So we want to set up and find what is y when x is 70. So we're going to cross multiply 35 times 70 to get 2,450. and then we're going to divide by our other number, that 140. So our answer would be 17.5. That is our missing y value. So moving right along, we've got researchers in Antarctica discovered a warm sea current under a glacier that is causing the glacier to melt. The ice shelf of the glacier had a thickness of approximately 450 meters when it was first discovered. The thickness of the ice shelf is decreasing at an average rate of 0.06 meters per day. Which function can be used to find the thickness of the ice shelf in meters x days since the discovery? So remember, it was 450 meters thick when we found it, and it's decreasing at an average rate of 0.06 meters per day, and we said it was x days. So let's look at that. 450 minus, oh, that looks perfect. This one would be multiplying it. We didn't need to multiply it by the 450. 450 was our starting point. It's not increasing, and on this one, once again, we're not distributing. Our next one, which value of x makes the equation of the problem true? So we're just going to solve this. We're going to start by distributing here and here. So we have 0.75x plus 0.75 times 20. We get 15. So plus 15 equals 2 plus 0.5x. Half of negative 2 is negative 1. Combine our like terms. There's none here, so we're just going to bring these down. 2 and negative 1 can combine, so we would have 1 plus 0.5x. So I'm going to move this 0.5x to this side. Those cancel, so 1 equals 15. And then that'd be 0.2x plus 15. Subtract the 1 from both sides. So I'm going to move this up because I ran out of room. So we still have the, oh, sorry, I meant minus the 15. There we go. So then those cancel, so we have 0.2x equals negative 14. Divide by 0.2 on both sides. So negative 14 divided by 0.2 would be negative 70. Oh, I made a mistake somewhere. All right, let's go back and check this. So right here, 0.75, 15, 2, 0.5, negative 1. Oh, I dropped off the 7.5 here. That's what happened. So instead of this should be 0.25, 0.25, 0.25, 0.25. So let's try that again. Negative 14 divided by 0.25. Easy way to find your own mistake. So this should be negative 56. All right, moving right along. A set of weights include a 4-pound barbell and 6 pairs of weight plates. Each pair of weight plates is 20 pounds. If x pairs of plates are added to the barbell, the total weight of the barbell plates in pounds can be represented by f of x equals 20x plus 4. What is the range of the function of the situation? So range, remember, is our f of x or our y values. So it's what would be spit out, basically, if we plugged in for x. So reading the problem, we only have 6 pairs of weights that we could plug in here. So we could only do 20 times 1 plus 4, 20 times 2 plus 4, 20 times 3 plus 4. So 20 times 1 is 20 plus 4 is 24. 20 times 2 is 40, 40 plus 4 is 44. 20 times 3 is 60 plus 4 is 64. So let's kind of take and start looking at these. So remember, we could also have 0 weights. So 20 plus 0, so it'd be just the barbell at 4. So we know it can't be A or C. And right here, they're in sets because each pair of plates is 20 pounds, so we can't skip that 24, so D couldn't be correct. Next one, what is the solution? So we're going to once again solve this. 8x minus 6x, because we're distributing, plus 12. Distribute again, 3x minus 18. Combine our two like terms here. That'd be 2x plus 12 equals 3x minus 18. I'm going to move my 2x. Cancel. 12 equals 1x minus 18. Add the 18. Those cancel. So x or 1x equals 30. Our answer would be C. What is the equation slope-intercept form of a line that passes through this point? So remember, slope-intercept is y equals mx plus b. So what I'm going to do is I'm actually going to kind of go a little backwards on this one. We're going to show a shortcut on this one. We're going to actually use the y equals, and plug these equations in. Negative alpha y equals 21 over 2 x plus alpha y equals 979 over 21. Oh, what did I do? I accidentally hit enter. Alpha y equals enter. There we go. 979 over 21. Clear these out. Plug in the next one. Y equals 2 over 21. X plus 979 over 21. Next one. Negative 21 over 2x plus 5. Oh. We're going to delete that, delete, move over. There we go. X plus 5. And then our last one in the fourth one, negative 2 over 21, x plus 5. So now I'm going to go to my table. Remember, we're looking for the points negative 447 and 216. So I'm going to look at the 2's first. So 2, that is definitely not 16, so it can't be A, not 16. Ah, that one's negative 16, so that's looking good. And then this one is also not negative 16, so we can do it. And then I just kind of want to check myself. Remember, we said the other one was negative 4. So scroll back over. Let's go up to negative 4 and check. Remember, it should be the third one, so y3 should have 47, so that would be my answer. Our next one. A bus travels 2 different routes, the green route and the blue route. The routes are different lengths. On Monday, the bus traveled the green route 6 times, the blue route 5 times, traveling a total of 52 miles. On Tuesday, the bus traveled the green route 12 times and the blue route 13 times, a total of 119 miles. So on this, we're going to actually write an equation for both situations. I'm going to make my green route my x, my blue route my y. So I'm going to keep that same pattern here. So I would have 6x plus 5y equals 52 miles for my first situation, because 6 times for the green, 5 times for the y or the blue route, and then 52 miles. My next one would be 12x plus 13y equals 119. I'm going to take and solve both of these for y equals. So move our x term over. And then we're just going to divide by 5 for everything. Those cancel, so y equals negative 6/5 x plus 52 over 5. Same thing here, move our x term. Those cancel, so 13y equals negative 12x plus 119. Divide everything by 13. Cancel, so our second one would be y equals negative 12 over 13x plus 119 over 13. I'm going to take these, I'm going to plug them into my y equals. So I'm going to go ahead and clear my calculator. Go back to y equals and plug both of these in. Oops, 5x plus, oops, wrong one. Let's go back, there we go. Our second equation. Okay, we're going to graph these. We want to make sure that we can see where they intersect each other. So see how I can see that? That's what I want to find. So we're going to go to second trace, and we're going to actually find the intersection. So option 5, enter 3 times. So it's telling me that they intersect each other at 4.5 and 5. So what this tells me is it wants the length of the green route. Remember, I labeled my green route as my x. So if we have an x and a y value, my x value is what I want. So that'd be 4.5 miles. Right here, what is the equation line that passes through this point and it has a slope of 0? Remember, 0 slope is a horizontal line. So if I have a graph, a coordinate plane, and I have negative 2, positive 7, that point would be about right here, and I have a horizontal line that goes through it. Notice this horizontal line crosses the y-axis, and it crosses the y-axis at positive 7. So y equals 7. All right, last 2 questions here. So right here, the graphs of K1 and K2 are shown on the grid. So K1, K2, which system of equation best represents this graph? So we actually want to find the equations. So we've got this first one, I'm going to start with K1. So K1 equals goes down at -2, and then we rise 3, run 1. So we'd have 3x minus 2. And then k2 equals, and we cross through 4 here. And then we go down 1, run 2, so it'd be -1/2 x. So I'm going to take one of these and I'm going to change it into the form that they have, which is standard form. So on this one, I'm going to actually, y equals 3x minus 2. So we want the x on the same side. So we would cancel those. So now we'd have -3x plus y equals -2. But remember, math people don't like a negative out here. So I'm going to switch all the signs. 3x minus y equals a +2. So that looks good. That one can't work. That one can't work. And that one can't work. So just by doing that first one, I have my equation. Next one, what is the value of x in the solution of these systems? Once again, we're going to solve for y. So we're going to move that over. So now we have y equals -2x minus 1. We're going to graph these. So we have -2x minus 1. And then for our second one, we have alpha y equals 1/2 x plus 4. We're going to graph them, make sure we can see them. Second trace, 5, enter, enter, enter. That would be our intersection. We want the x value, so our x value is -2.